x, what's the m value? -0.5. And what's the b value? +4. That's it. That's the equation of the line that has a slope of 1/2 and a y-intercept of 4. Do you see a similarity to the last unit? Yes, kind of, maybe. Exact same thing, we're going to determine the equation, except this time they haven't stated it, they've given us a graph. And you notice the graphs are different from last unit. Last unit they had a situation, so it was sometimes time and speed, it was cost and number of objects. And typically it was restricted to the first quadrant because time can't be negative, cost can't be negative, number of objects can't be negative. All we've done is just extend the line to be in all 4 quadrants. That's the only thing that's different, and we've taken away the context. Here's your method. We're going to find by looking at the y-intercept. We're going to find m by choosing 2 points and counting the rise and run, and then we're going to throw it into the equation. Okay, so we need to have m and we need to have b. B comes right from the graph, and the y-intercept is where it crosses the y-axis. What's the value of b? 1. The slope piece is exactly what you did yesterday. Yesterday you picked any 2 points and then you decided what was the rise, what was the run. We're going to do the exact same thing. What other point am I going to pick? I don't know. Let's go 1, -1. Why 1, -1? No reason. It was just kind of a nice point and it crossed through the boxes and it was nice and even. So we need to know the rise and we need to know the run. You just need to be careful if you're going down instead of going up, which means you're not rising, you're actually dropping. It is negative. So how many units for the rise between these 2 points? -2. You can't see that. And the run is? I heard a little quiet little one. Yes? And can we reduce -2 divided by 1? -2. Okay, so just making some notes. The negative comes from the fact that it's dropping, not rising. Now we're doing exactly what we did above. We know y equals mx plus b. I need to take out m and I need to take out b. And I just need to put in the numbers they're equal to. So the first one, the equation is y equals -2x plus 1. How are we doing so far? Okay, the second one, first thing we do is grab the y-intercept, so we check the y-axis, wherever it happens to cross is b. For this one, b equals -5, because it's underneath. Doesn't matter what other point you pick. I try to find a point where it crosses nicely between the boxes, so I'm going to pick this one, 2, -2. Again, because it's a nice crossing point. What's the rise? 3 or -3?
No, 3 is going up.
Why +3? It's going up. And then it's because it's to the right, it's going to be 2. Confirm, up 3 units over 2. Can we reduce this fraction? Nope, so we just leave it. And we'll get a lot of fractions when we're calculating m, so don't let the fractions scare you. It doesn't mean you've done something wrong. Y equals mx plus b. We're going to say that 500 times before the end of this unit. Y equals, put in m, which is 3 over 2. Keep x. Put in b, which is -5. Grab your colored card. You want to write down slope-intercept form of a line. And I would write down the words as well as the equation, slope-intercept form. That's our first orange paper that's on the wall over there. So linear equation, slope-intercept form, all means the same thing, y equals mx plus b. The last skill we're going to do today is graphing a linear function given the equation. If you take nothing else from this unit, this is the single most important skill. This is graphing a line. We're going to use this a bajillion times between now and the exam, and it's going to come back next year and come back in grade 12. So if you learn nothing else, learn how to graph a line. Step number 1, isolate y. And what this really means when we get the y by itself is we're putting it into y equals mx plus b form. Because in y equals mx plus b form, the y is all by itself. It's isolated. Step number 2, plot b on the y-axis. Why do we put b on the y-axis? What is b? The y-intercept, right? And that's what goes on the y-axis. From there, what we need to find is a second point. This is where m comes into play. So from point B, use the rise and the run. From B, use the rise and the run to count to the second point. From B, use the rise and run to count to the second point. Last step is join the points. And don't forget your arrowheads. This is one of my favorite things to do because this is a pre-cal skill and it looks like it should be really hard, but once you do a few examples, you're going to see it's super easy to graph lines. But you show that to someone who hasn't done pre-cal, they'll cry. Okay, so let's look at the first example. Y equals negative 2 over 5x plus 4. By looking at this, how do you know this is a linear equation? How do you know this is a line? Because there's no exponent greater than 1. And you may think it's silly I keep asking you that. It's because next year we're going to start adding in other exponents. And so you need to be able to know what's a line versus not a line. We know it's a line because the greatest exponent is 1. We start with the last number, which is b. b represents the y-intercept. So we go to the y-axis and we put a point at 4. The second piece we use is the slope. Negatives go with the top, so it's either going to be a rise or a run. The bottom is always to the right. So negative 2 over 5 means that you're counting down 2 units over 5 units. Why is it down 2 and not up 2? Because it's negative. So go back to B, put your point or your pencil there. We're going to count down 2 over 5 and put a second point. Down 2 over 5. Okay. I'm just going to mark on the first one what we did. So 2 down, 5 over. 2 down, 5 over. You don't normally need to write that. I'm just showing you for the first example where that came from. The last step is the funnest and the easiest. We grab a ruler, we join the points, and we put arrowheads on the end. That's it. That's graphing a line. Why do we need those arrowheads? Because lines keep going forever and ever and ever and ever and ever and ever and ever. Y equals 4x minus 6. We start with the b, which is the last number, which is minus 6. Where do we put it? On the y-axis, because its definition is the y-intercept. Now we're going to use the m value, and sometimes when there's just a number, it throws people off because we need a rise and a run. Just remember what's under the 4 that we don't see, but we know it's there. There's an imaginary 1. So there's always a fraction for m, even if you don't see it. This means we're going to count 4 units up and 1 over. Why are we counting up this time and not down? Because it's positive. So go back to B, count 4 up, 1, 2, 3, 4, 1 over. If you find it hard drawing the line with 2 points, you can actually add more points. I'm going to go to that second point, and I'm going to count the slope again. 1, 2, 3, 4, 1 up. Or sorry, 1 over. Count again. 1, 2, 3, 4, 1 over. All the lines or all the points should be on the exact same line. How are we feeling so far? This is the single most important skill from this unit. It's going to come back and haunt you forever. Okay, let's look at C. What do you notice about C that you didn't see in A and B? Yeah, we got to get rid of that plus 1. So step 1 is we need the y by itself because we need it in y equals mx plus b. How do we get rid of plus 1? Minus 1. Okay, so just regular algebra skills to get the y by itself. So on the right-hand side, I'm going to have that minus x. And then I'm going to have plus 1. If we didn't isolate that y, we would have the wrong y-intercept. That's why it has to be by itself. Okay, where do we start for graphing? Start with the 1. Where does it go? On the y-axis. All I have in front of the x is a negative. I don't have any numbers. Yeah, it's a negative 1 over 1. Even though we don't see it, we know the numbers are there. So this is going to be 1 unit down, and then 1 unit over or to the right. And again, some people like to have more than a couple points to join the line, so I just keep counting 1 down, 1 over, 1 down, 1 over, keep doing it over and over and over. All the points should form the exact same line. Don't forget your arrowheads. So even if you don't see a number for the slope, there's numbers there. We just don't see them, but we know that they're 1s. Why did I count down and not up? Because of the negative. Is y by itself? No. How do we get rid of a coefficient of 2? Okay, watch what I'm going to do on the right. I'm going to divide each of these by 2. Okay, so if you divide one thing by 2, you got to divide everything by 2. So the 2's cancel on the left, which leaves me y, which is good. That's what I want. What happens on the other side? 4x minus 3. Go ahead and graph that. So I got my y-intercept at negative 3. Now I'm confused. Tell me what to do. Okay, up 4. Now here's a really common mistake. People go, well, there's nothing underneath, so it must be up 4 and I'm done. It's over 1. So don't forget that there's that imaginary 1, so it's going to be over 1. Who had the exact same line? Awesome. Turn to someone in front, behind, beside you. Tell them how to graph a line. Okie doke, let's look at letter E. What do you see in E that you didn't see in the other questions? Brackets. So we're going to deal with the brackets first. Well, this is just grade 9 algebra. What do we do when there's brackets? What's the word I'm looking for? Starts with a D. Distribute. She got it. Okay, so I'm not touching the left-hand side yet. I'm leaving that y plus 2. I'm just getting rid of the brackets on the right. 3 times x. 3 times negative 1. Now I'm going to go and get rid of this plus 2. What's the opposite of adding 2? Subtracting 2. On the right we have offer of 3x minus 5. Graph it. You look very pretty. Were you at a dance thing today? Yeah, you don't just usually walk around with jewels on your eyes? I would just sit and watch and then catch up once we're done. Okay, you tell me. Tell me how to graph this line. Tim.
You would want to make the y-intercept -5.
And that's over here?
No, on the y-intercept.
On the y-axis, yep.
And then you would go up 3, and go over to the right on 1.
Why do I want to go over? There's no 1 there.
Well, there's always 1.
There's always a 1 there, we just don't see it. Who had the exact same line? High fives. Who also had arrowheads? High fives. This is as hard as it's going to get. Fractions, brackets, crap going on everywhere. Who likes fractions? Who does not like fractions? So let's go with the who does not like fractions. Okay, I'm going to show you. If you like fractions, you're going to pause, just watch, then I'll show you. If you don't like fractions and don't want to deal with having to add and use common denominator and everything else, here's a trick. What's the opposite of dividing something by 4? So what I'm going to do is I'm going to multiply it up to the left-hand side. So I'm going to put the 4 in front. I'm going to bracket my y plus 1. And on the other side, I've got that 3, and then a bracket x minus 2. Again, you don't have to do this as a first step. This is just going to help if you don't like fractions. All I did was get rid of the dividing by 4, which is multiplying by 4. Now I'm going to distribute each side. 4 times y. 4 times 1. 3 times x. 3 times negative 2. The next thing I'm going to get rid of this plus 4, just like we got rid of all the numbers in the other steps. So what's the opposite of adding 4? Subtracting 4. So on the left, I still have the 4y. On the right, negative 10, confirm. How do I get rid of a coefficient of 4? And if I divide something by 4, I have to divide everything by 4. Can I reduce or divide evenly 3/4? Nope, so I'm just going to leave it as 3/4. Can I divide or reduce 10 on 4? Okay, what is it reduced to? 5/2. Pause, wait for the drawing. If you don't mind fractions, let's go to the other side and I'll show you a different way how to do the question. I'm going to do this way exactly what we did above. I'm going to start with the distribution. So y plus 1 is going to stay on the left. 3/4 times x. 3/4 x. Here to multiply fractions, it's top times top, bottom times bottom. So I've got 3 times negative 2 on the top. And then 4 times 1 on the bottom. How do I get rid of a plus 1? Now I need to deal with adding these numbers together. And this is why I do the other way, because I just hate having to deal with common denominator. If you don't mind fractions, then do it this way. Common denominator between 1 and 4. So I'm going to keep the 6 over 4, and I'm going to put the second fraction over 4. How does 1 go into 4? Times 4, so 1 times 4 is 4. How do we subtract fractions once we have common denominator? Keep the bottom, subtract the top. -6, -4, -10. And we're exactly where we were on that side. If you don't mind having to multiply and subtract and add fractions, do it this way. If you're like, then do it this way and you don't have as much fraction work. Okay, completely up to you. You get the exact same answer in the end. Okay, what the heck do we do with 5 on 2? Where am I going to put that? Well, what's that as a decimal? Five divided by 2. 2.5. So I'm going to go to the y-axis, and where am I going to find negative 2.5? In between negative 2 and negative 3. Now I go to the slope. What am I counting? How many units up and how many units over? 3 up and 4 over. Well, how am I going to count when I'm in the middle of a box? I'm going to count in the middle. So I'm going up to the next middle, to the next middle, to the next middle. So I should now be between 0 and 1. And I wouldn't actually put a dot there because I have to go over. I'm just showing you where we are. And then how many units over? 1, 2, 3, 4. Halves are the worst fractions we're going to give you. We're never going to ask you a y-intercept of 7 on 9, for example. Halves are about it.